than Morthy. That's even more ridiculous. Let's see if I can make this work now, right? Let's see. All right. Do lights or
I think the panel behind you. I swear.
Oh, yeah.
That's good. Yeah.
Okay.
Okay.
There we go. So, yeah, I'm very happy to be here. As Morthy mentioned, I'm the new executive officer of the department. And I'm also happy to talk about a few maybe thoughts, ideas about software development. Software development principles is kind of what Morthy asked me to talk about today. A lot of this you might already kind of just know. A lot of it comes down to common sense. It's stuff you, I'm guessing, are seeing in software design and documentation. But let's see if we can kind of put some of these things together. The kind of top level, what I had in mind was successful software development. All these projects that you're working on tend to be either maybe as individuals or more likely as team projects. And that's something that I know you fight with in SD&D and also in the real world. So here I just have a few bullet items about software being usually a team effort of some sort, requiring some good coordination, collaboration, and so on. You all know that, I would say. And you probably also well know how difficult working with some team members can be, though not in this group here. I know that's not the case. But one thing which is crucial to that is documentation, which generally folks like you and me in the room here don't really like to do. But if we use things as you're already doing with blogs and wiki pages and Google Docs, or even cooler than Google Docs, this briefcase thing I ran across earlier today, document project goals and requirements that users might have, or even your own kind of thoughts, requirements, timelines, milestones, task lists, test cases as well. Something crucial to really getting the code to be really solid, bulletproof is writing test cases. And often that happens first, right after you get requirements down and maybe some project goals, figure out, well, what should this thing do? Let's write down all the test cases. So that might be some of the things you're doing already in your documentation, or some things to think about for your documentation. The challenge here is this right here, up to date. How do you keep the documentation up to date? That is crucial to the success of a project. But one thing which I think a lot of folks get in trouble with, and I've seen this in industry before I came here, is too much documentation is a very bad thing, because then there's just way too much to maintain. So much like writing code, writing documentation, you're trying to find that balance of just enough documentation to be useful to others. Right? Version control, I know that you're using that, and that's crucial to pretty much any open source project, be it with the code or even the documentation as well. And I put here that version control provides benefits not only to teams, so that they can collaborate and share files and make modifications and so on, but also those one-person projects. So some of these projects you're just starting out individually, it still is very important to have all the version control, because it creates a log of the changes that you've made, right? So you go and update or check some files in and describe what you changed and so on. There's a good history, useful for you, and also because this is so often true, right? Those one-person projects often evolve into team projects. Either other folks get on board, or maybe that one person just disappears and leaves the project behind. So no question about it, this documentation in many forms, right? Version control down at the code level, and also at the maybe higher level requirements and so on. All very crucial to making these projects work. You guys do coding standards at all with any of your projects? Not really, no, yes, yeah, maybe, sort of. How about written coding standards? Do you have a written coding standards document? Yes, with a
It's usually someone else's, but yeah.
It's usually someone else's. There's a lot of good ones on the web, certainly. But yeah, I have a link right there to some good information. But something which I've done also back in industry is creating some of these documents for the development team. And it helps, right? The bottom line kind of aiming for readability, right? And so that's what these things really help with. There's some general things they often document: coding and indentation styles. Who likes the curly bracket on the end of the line? Who likes it on a separate line? It looks like you're outnumbered, end of the line people. But so yeah, that would be one thing you put in this document, right? So where do you put the curly brackets? Where do you do things like that? Some simple things just to have consistency, to increase readability. Naming conventions, variables and functions and so on, classes. Commenting styles, you might have standard comment headers. And a lot of this takes discipline and so on to actually implement and maybe enforce as well, especially if you're a one-person team. One thing which is not always as clear-cut as these is safe approaches to programming. And there's some good examples in here. Right? So different ways, like for example, operating systems, network programming, lots of system calls always have to check the return value. Right? Are we getting an error back? Even malloc, right? That could fail. Likely it's not going to, but those kinds of things, those safe approaches, we want to have that as part of the coding standard, and that makes sure that your code is going to be bulletproof. So that's some of the maybe other thoughts there. Let me click on this link. This has a lot of good information, a lot of different formats here as well. Actually, you can see where I was earlier. Writing robust programs. Let's take a look at that one. But there's a whole number of suggestions and guidelines and so on. A lot of these are not hard and fast rules, but they're guidelines, suggestions as to what you should do. Back here's the malloc stuff down here. Here's the, check every system call for an error return. Unless you know what you're doing, unless you know you wish to ignore errors, which you probably ought to be in a big comment above that or something, right? So, I'm ignoring this error on purpose. Here's why. But anyways, these kinds of documents can be very helpful, if not to go to and kind of enforce, or even to use in coding reviews or code reviews, which you guys are doing code reviews, I think, right? Yeah, I see only one person nodding their head. That doesn't convince me that you're doing code reviews. Code reviews are extremely useful. Okay, let me go back here. I think that's on the bottom here. They're very useful and valuable for improving the quality of your software, right? And again, it's kind of the collaboration idea. It's also a proofreading even for yourself, right? If you ever leave code behind and come back after a long weekend, you probably can go through it and find many ways to improve it. So the code reviews are nice, especially in a group, to do that and maybe use some of these things and look for these where the rules are being, maybe broken or not followed 100%. Look for ways to improve that quality of the software. So usually it doesn't come down to things like this, though. Usually it's not, hey, you got a curly bracket over here when it should be over here. More it's these kind of more general, why did you do it this way? Wouldn't it be maybe more efficient or safer to do it this way? Hey, you're not checking return values on your system calls here, or things like that come out of the code reviews. Another key thing I would say, especially in this group here, is you're all learning about a lot of new stuff along the way. And that's what these things provide as well. So even if you're a newbie programmer, so to speak, a code review is going to be a great learning experience for you, right? You sit and you watch going through code together, you hear the comments, the questions that come up, and you realize when you go back to your own code, maybe how to write better quality code at that point. So it said on your website you're doing code reviews, but apparently there might be some question about that. Is that off the record? Maybe I shouldn't say that on the tape. But I would strongly suggest doing code reviews. In fact, look me up. I'd be happy to jump in to do some code reviews with you. Those are always fun. And usually find dozens of things that could be made better. This right here is a long list, and if you're in NetProg, your operating systems, all these words that end in Y. Most of them do. And we can change them to end in Y as well. I know we did that in class. But anyways, large-scale software development is something we don't often think about going through, 4 years here of undergraduate work. We don't often talk about large-scale software development, maybe in SD&D. But things really change when we have to deal with large-scale software development. And in terms of what I mean by that, I try to write a few ideas here. As software systems grow in terms of certainly usage, your user base is going to grow, hopefully. Scope, covering many more features, scale, just the size of it, how many people are relying on this software system. as all of that grows, that ugly word maintenance comes up. And you all know that that is easily 50+%, maybe 60, 70, 80% of the cost of software projects in general. You write code once and then you maintain it forever, essentially, right? So that's a very, something to be afraid of, I guess, in the software world. So, important aspects of quality software, certainly maintainability, whatever that means. I guess it means some of the things we just talked about, documentation, good collaboration, good version control, a lot of things you're doing already. But not only maintainability, but also maintained. I know with open source projects, some of them do kind of hit a dead end and no one's maintaining them, which is not a good state of affairs. So also maintaining and keeping up with maintenance, whether it's bugs or what else, new features and so on. Usability testing. Again, one thing I would strongly suggest, like I mentioned, is getting your test cases down, and in particular, how usable are your things. I always bring up the Maple example. Right? Maple can do anything. User interface, forget it. No usability there, right? So that's always something very important for your software projects to think about. Extensibility. Everyone know Apache. Dig into the config files there. Something nice about that. I'll try to. I think I can jump in here and look at one real quick. Maybe I can. There we go. Here's a machine running some version of Apache. Well, you know, if you know anything about Apache config files, well, first of all, this is almost 1,000 lines long. That shows you it's very configurable. But the extensibility here is, if I scroll down a little bit, the key thing is the modules that I'm looking for here. Let's see. There we go. So the load module, right? So all these various modules, if we want to extend Apache, it's very extensible, right? We can create our own module, compile it down, I guess to this .so kind of file and so on, and just add this config line. And then maybe add specific config options about that module. And so, for example, something I added to this last semester at some point was Python, right? I wanted to run Python in there, so just uncomment that or paste that in, and there you go. So the more that you create your systems, usually this is a much later down the development process, I suppose. But as you're developing your systems, often you think about extensibility, and maybe this over here as well, generalization, right? I think a lot of you do this in code. You're coding something up, and it might be very specific, but as you see other uses for it, you kind of generalize it, right? The function suddenly can do maybe a variety of things, right, based on what the inputs are. So you often do that with config files, with the Apache example. So all these things go together: extensibility, reusability, generalization, and then these guys here are certainly reliable. You want your code to work, so testing is important there. Consistency, I want to certainly be consistent. So lastly, I just have here, and go back to the show here. Whoops. Lastly, Martha asked me maybe to describe some of the stuff going on in the department, and really here's a link that should be hopefully up to date, but a place to kind of find, you know, where potential projects could be developed. Might be this site here. There's a number of centers. You saw the previous presentation, of course. There's the Tetherless World Constellation, data science we just saw, and a bunch of others here. So anywhere on our site, whether it's this research group or even just browsing through the faculty and see what they're up to, there's a lot of good potential ideas in there that you can get involved with. So, good. Other comments, questions? Kind of general stuff, but good. Thank you. Who's up next, sir?